x over 3 states that we would have f of x over 3 from.
I think so. I had a little trouble hearing you, Raul, but I think so. I mean, basically, if we factored out that 1/3, we can always factor out constants. What's 1/3 times 11? 11/3. So this was just to be a little bit of a kind of a review into area. And now we're going to just look at, that's not the one I want. If you want to go into your content library, you can see what we're going to look at today. But before, like, I just want to jump out and kind of go at just a big lens because I can tell we need it. If I had a curve, any curve, you should probably put this in your notes. If this is some curve f of x, and I was looking for the area from A to B, all this area here, what would that area equal? Nia, how would I write that as an integral?
The integral of f of x from A to B.
Anything else?
Dx.
Perfect. Yeah, that's all that is. But what if I had a 1/3 in here? How would that affect things? All that would mean is that I have 1/3 of whatever that answer was. And so since we knew in our particular problem, based on the picture, all this was equal to 11. That's why the answer was 1/3 times 11, or 11 over 3. Does that make sense? As review, does that make sense to you as well, though?
Yeah.
So now I'm going to switch up my picture a little bit. I'm going to introduce another curve. I'm going to call this curve g of x. Got two different areas. We've got the green and the blue. I want to know what is area 1, what is area 2, and what is the total area between the two curves. Take 30 seconds of think time. What do you think each of these would be? Of course, in integrals, right? So we're just going to write these as integrals. Another 15 seconds. Hopefully you're writing all this down in your notes. If I'm going too fast, please holler. Jessica, what do you think that first area 1 is?
Would it be the integral from area from A to C, but minus probably the bottom area?
So tell me more, like what should go, I've got a parentheses in here and a dx. What should go in that parentheses? Do you remember, Jessica?
I'm not sure.
Okay. What if I started to remind us that these are really just a ton of infinitely thin rectangles that we're adding up? Manuel, any idea? And the thickness of this rectangle is dx. What would be the height? Go ahead, Anna. I see your hand up.
F of x minus gx, maybe?
Yeah, exactly right. F of x minus g of x, because that's really our height, isn't it? And our dx is our thickness. Brittany, what about area 2? What's it going to be?
The integral from C to B, gx minus fx
Very good.
dx2.
Manuel, what happened between that first one and the second one? Like, what do you notice specifically about the difference between area 1 and area 2?
In area 1, it's f of x minus g of x, and the other one, it's the other way around.
Why is that? Like, what caused that?
Because in the first one, f of x is at the top, and then the other one, g of x is at the top.
That's right. If we're really thinking about this height, it's always going to be upper minus lower, isn't it? So that's just kind of a little quick review on area. Giovanna, what would be this last question, the total area between the two curves? How would I deal with that?
Wouldn't we add both areas, both the integrals?
We would. We would essentially have two integrals, right? From A to C, F minus G. I'm kind of shortcutting. We should have all those X's in there. Would it be plus or minus the integral from C to B of G minus F?
Plus?
Yeah, it should be plus. Or we could also do minus, but then we would have to we'd have to switch and go the lower minus the upper. Like, we could do little things like that. Can anybody think of how I could write it in just one integral? So just one integral. What would my limits be? And what would go in here? Katie, any idea?
Oh, I think this is gonna be the integral from A to B, and then in the parentheses is gonna be A1 plus A2, so
It's tricky though, because like we can only do one integral, right?
yeah.
And
Also,
F, what's that?
so is it, wait, is it 2F minus 2G then?
Not really, because we still need some combination of F minus G or G minus F, but they switch. There's something sneaky here. Anybody remember what you can do? Cesar, do you remember? Casey, Lynn, Oswaldo, anybody? What if we used absolute value? As soon as we use these absolute value bars, it turns all the negative area into positive. And so that was the key thing that I wanted to remind us about. If you ever have an upper and a lower curve that switch, top and bottom, absolute value bars can work to write as only one integral. What's really happening is, if we were to write the integral of f minus g from a all the way to b, this first green area would be positive, the second blue area would be negative, but because we have absolute value, we'd basically be saying plus a negative, and the absolute value bars would turn that one into a positive. Does that make sense? Oh, Mr. Heffron, that makes total sense. You totally lost me, Heffron. What on earth are you talking about? Which is it?
Makes sense.
Shannon, how about you?
It makes sense.
Okay. So that is a little bit of a review on area. Now I want us to remind us a little bit about volume. And for that, I'm going to go to a particular website that'll show some things. Let's see, how do I get there? I think it's here, GSV. And so we're going to first look at things as we revolve. And so just as kind of a reminder, this shaded area here is just the area under a curve. What's happening as I revolve? What shape is formed? Lynn, what shape is formed?
Cylinder?
Yeah, it's a cylinder, right? What are the dimensions of that cylinder? Like, what's key? If you were going to find the volume of a cylinder, what would be what?
Oh, sorry. Can you repeat that again?
Yeah, do you know the formula for volume of a cylinder?
I don't remember.
Oswaldo, do you remember?
For a cylinder,
Uh-huh.
wasn't it like height times the area of the circle? I think it's like,
Yeah, exactly. Area of the base or area of the circle times the height. In this case, the height is really the distance along the x-axis, isn't it? So if I think about making this n, gosh, what would this look like if I made this n 10? I've got a lot more of them, right? Let's go to 100. Holy crap, like they don't even really show up, do they? But that's what we have when we take an integral. We have so many little cylinders that their heights are all really small, aren't they? And so as I revolve only one of them, what dimension is that height? Is it in the X or the Y? Leonella, what direction is that height of that cylinder in? Are you with us, Leonella?
I'm sorry, can you say it again?
Yeah. As you look at the picture on my screen, this cylinder is really, really, really small. Like, it's not very tall. It's got a pretty good area of the base, but its height is really small. Is the height of that cylinder measured in the X or the Y direction?
The Y? Or the X?
Yeah, it's really in the X, isn't it?
Yeah.
And then as we revolve everything, we get our volume. And so I'm going to kind of clean this up a little bit. We're just going to have one of them. And I'm going to take this picture to our OneNote. What would be the formula for the volume of this? Just assuming this is just f of x, just like you see it. Let me give you a second.
Mister, you're muted.
Yeah, I think somebody's muting me because I'm not unmuting me. So please don't do that if that's you. What do you think, Casey, is the volume here?
The integral from A to B, and then I don't know, but it has to do with the X just because the height is changing each time, but I don't know.
Yeah. So like this thickness is definitely dx, isn't it?
Yeah.
And you're right, the height is always changing. Raul's got something in the chat. Let's have a look at it. It says y equals pi from A to B y2, so maybe y squared dx. I think this is what I would say Raul put in the chat. Is that what you got, Raul? Yeah, y2 is squared. Perfect. So that's what he's thinking. What I want to talk about, though, is this shape right here. What is it? What is that green shape?
A circle.
Yeah, that's a circle. That's really the area. And then the dx is our thickness. And those two things give us volume. The only way we could possibly get into the third dimension we need for volume. So what's the formula for area of a circle, Anna?
Is it pi r squared?
Yeah, it's pi r squared. What is r in our case? Is it the height up to the curve? What do you think, Giovanna? Is r the height up to the curve, or is it something different?
It's f of x down
Yeah.
to the axis.
Yep, perfect. So we could think of it as f of x minus 0, because 0 is the y-axis. So that's why Raul was totally right. We probably should have written it as f of x squared instead of y squared just based on our picture, but he's totally right. So nice job, Raul. The most important thing, though, as we think about reviewing volumes, this is what I want to make sure goes in your notes. Volume will always be the integral of some area times some thickness. That's all it can ever be. And so Raul picked it out, and probably others did too. The area in this case was the area of a circle, pi r squared. Give me a thumbs up in the chat if it's coming back, and a thumbs down if you're like, Mr. F, and I've never been more confused in my life. Or something like that, like you're just confused. So I want to see from everyone a thumbs up or a thumbs down in the chat. Thank you, Hasey. Perfect. You can just thumb up to other things so that our chat doesn't like blow up. Either somewhere in between thumbs up, or I haven't seen any thumbs down yet, so I guess that's good. Okay, so we're going to look at one more. I'm going to make myself another little picture. This is the graph y equals 4 minus x squared. So it's going to meet the x-axis at 2 and the y-axis at 4. This is my region, and I'm going to revolve this around the x-axis. Okay. What I want you to do is, the first thing I want you to do is just draw this on your paper. 1, draw this. 2 is going to be draw as best you can the 3D solid after revolving. And then 3, write the integral. And of course, your integral will be the integral from A to B of some area times some thickness. While I take roll, do that in your notebook. I think it's going to be way easier to do that than if you want to put it in your student page because you've got a great stylus, that's fine too. But either in your OneNote in your student page, make yourself a new tab, or on a piece of paper. And I'm going to jump to take and roll real quick. the other thing I want to do, I'm going to put in the chat. If you're in step 1, 2, or 3, I want you to thumb that so I know where we're at. Because I don't want to rush us, but I also don't want to be waiting when everybody's done. Right now, which step are you on? Okay. Lots are into step 3. I'm going to pick up my drawing. I want you to check your drawing against mine. If we revolve, then this entire curve swings around, and I have a series of circles, again with thickness dx. Okay. So Jorge, hold on a second. Tell me what you have so far with your integral. So this is specifically to Jorge. Totally fine, Brittany.
So what I have is from the integral of from 4 to 2,
Okay.
or from 0 to 2, I mean.
Okay.
Pi r squared times 4 minus x squared.
Okay.
That's guessed so far.
Okay. You've got all the right stuff there and maybe a few extra things. And then there's one thing you are missing. Do we want dx or dy for this guy?
Dy?
Because the thickness of this guy is measured along the x-axis, we really want dx. Because this is a cylinder that is got a radius in the y, but a thickness in the x. And so here's my question. What is the radius that Jorge correctly identified in the formula? What is that radius in terms of our function, Giovanna?
The radius?
Yep. What is it in terms of that function, y equals 4 minus x?
4 minus x squared squared.
That's right. I mean, what the radius itself is just the 4 minus x squared, isn't it? But then when we square it, it becomes squared. And so, Jorge, you just didn't need that 4 minus x part. Everything you had was perfectly right. So what I would have had for a final answer is pi from 0 to 2, 4 minus x squared squared dx. The dx was the thickness, and the 4 minus y squared was the r. Brittany, is that what you thought? So the one thing that I want to think about, what would have happened if everything stayed the same, but I didn't revolve around the x-axis, I revolved around a line slightly below. We'll call this y equals -2. In our last minute, who can kind of articulate how things would be different? Go ahead, Anna.
So wouldn't it have like a gap in the middle, sort of like a little donut in a way?
Exactly. If we think about what that thing looked like, we've got this gap in the middle, and there's a donut cut out of it. And that donut in this case is always the same that we've cut out. And we've got this green part above and this green part below. What would the volume equation look like, do you think? Would it still be 0 to 2, Hasey?
Yeah.
Okay. Do we still need a pi? Keep going, Hasey, just because.
Yeah.
Yeah, we still need a pi because it's still a circle, right?
Yeah.
But is it just one circle?
No, it's 2.
Yeah, we had to cut that donut part that Anna was talking about. This is the hole in the donut. So how do we deal with that with our integral as well, though? Do you remember?
I think you have to subtract the same process you did to get the rotation, but
Okay.
the middle section.
So it's sort of like we have a big R, call it capital R, and a little r, call it the inside radius. What's going to be the capital R, Oswaldo?
That's going to be the total.
Okay, so if I were to measure it from the center all the way out to the end, what would be this big R on my picture? What will big R be in terms of everything else? Is it still going to be upper minus lower? Go ahead, Giovanna.
It would be the radius from y equals -2 all the way from to the function.
Okay, how could we write that mathematically? Like, what is that? What's the upper side of that?
4 minus x squared minus 2.
Almost. Minus a -2. Because, Giovanna, do you see how that axis we revolved around was already negative? It was below the x-axis.
Yeah.
And so it sort of makes sense. What's a negative and a negative?
Positive.
Yeah, and our radius got bigger by moving that axis down. Because we moved our axes down, the radius actually got bigger. And so we could think of this as 6 minus 4x. And that whole thing gets squared because we have big R squared minus little r squared. Katie, what's little r?
The little r is 0 minus -2.
Yes, very good. The little r equals 0 minus a -2. Well, that's really just 2, isn't it? And we have to square it. So for that donut problem, we're looking at what you see here highlighted in yellow, circled in yellow. But the key components, whenever we have a donut, we're always going to have pi from a to b, some big radius squared minus some little radius squared dx. And the homework that I sort of had, it's got more than this. I thought we might get a little farther, and so I need to just tweak that homework a little bit before I send it out. But it will be titled 8.28 homework, and it will show up in your student pages. And then I'll try to get a Google Classroom alert out. Pretend that I know how to spell, so that you know just what the homework is. Does that make sense? Just tell me, unmute for like 30 seconds. Tell me what went okay in class, what could be better. Like, help me with that kind of thing, because I feel like we're off to a pretty good start, but I don't want to presume. Mr. Efron, could you share that page onto my student page for reference? So you're talking about the page that I'm doing all this work on? Is that what you mean, Brittany? Okay, I can, but can't you see it because I put it in the content library? Like, you should be able to see it, and you'll always have reference to it. Do you also need it on your student page so you can draw on it, or is it okay to just leave it here? Okay, so you're okay if I leave it here as long as you have, I don't really remember laughing out loud. You don't really remember volumes and areas, Hasey, or you don't remember what could be better?
I don't know. I just don't really remember areas and volumes. I kind of suck in that area.
So
Yeah.
was this helpful or was this not enough? Does
No,
that
this
make
was
sense?
helpful. I just need
Okay.
to practice.
Yeah, well, that's why I'm going to give you a little homework.
Yeah.
That will help you. But anything else? The donut problems always mess me up. Totally agree, Ro. We're going to do some more donuts. But the biggest thing, like, and this is for all you guys, and last year, these guys eventually got good at this too, like you will, but they hated when I said, draw a picture. Like Anna's pretty natural at these because she can just visualize it really well. But the biggest thing is drawing a picture. And I'm going to jump off so that you guys can go to class, your next class. So we're going to practice some more tomorrow, and we're also going to work on some cross sections. Go ahead, Giovanna.
Can you pull up, like, can you scroll up a little bit?
Is that better?
Yeah, thank you.
And then one more thing, Giovanna, because this should be recording in time. Can you go to your OneNote on the content library page and see if you don't have it all there for you?
Okay.
Because it should be there. That's the nice thing about OneNote. Yeah, Oswaldo, go. Everybody should go. Unmute and say goodbye to each other. It's all there. Great. Thank you, Hasey.
See ya.
See you guys.
Bye, Mr. Epelon.
Bye.
See you Monday.
Bye, Mr.
See ya.
Bye. Good job today, Jorge. Good job, Leonella. Good job, Manuel. You guys had a great day. I got to go, though, and so do you.
Bye, Mr.